All right, this video will finish up section 7.6 day 2. And we're going to look in this video at a typical IB paper 2 type question. And you'll notice that there's a lot of intermediate steps in this one. So it's a little bit different than the way your typical AP calculus question is phrased. So I have two situations. I have a waste paper bin designed by Nadia, and I have a waste paper bin also designed by Marin. The part about Marin is in a different font only because I could not get her part to copy properly. So I just wrote it on there myself. But the way the actual IB question is worded, both Nadia's situation and Marin's situation are given at the beginning. Both of them are creating a cylindrical waste paper bin, and both of them have a volume of 8,000 centimeters. Now, the way they are going to actually construct the waste paper bin is different. So Nadia first. Nadia decides to make the radius of the bin 5 centimeters. So question A says calculate the area of the base of the waste paper bin. So I see that the base of the waste paper bin there is a circle. I remember that the area formula for a circle is pi r squared, and they give me r to be 5. So I'm going to substitute that in there. And I already typed this in my calculator to save us some time. 3 sig figs, this is going to be 78.5 centimeters squared. And again, be really careful to put your units on there because you don't know when a unit penalty is going to come. Okay, so part B says find the height of Nadia's waste paper bin. Well, I know a couple things about the waste paper bin. I know that it is a cylinder, I know its volume, and I also now know the area of the base. And I remember that the formula for volume, I'm going to write it up here where I have more space, is the area of the base times the height. Well, height is what they're asking me for, so I have everything I need. Volume is 8,000. Pi r squared is exactly what I have right here. So I'm going to put 78.5 dot dot dot. I kept that whole value in my calculator like I'm supposed to. And then I have h that I'm looking for here. So dividing both sides by 78.5 dot dot dot, I end up with h approximately equal to 101.9 blah blah blah, which is going to round to 102. And this time height is a linear measurement, so centimeters on that. All right, and then part 3, the total external surface area. So surface area, let me change colors again so we can keep all our stuff straight. Surface area, which I usually put SA, but I noticed that the IB people usually just put A. So surface area, I have that circle on the bottom. And then I have the rounded part. And remember, we looked at this in class. When you unfold the rounded part, it makes a rectangle. And the height of the rectangle is the circumference of the circle, and the height of the rectangle is the height of the cylinder. So, I'm sorry, the base of the rectangle is the circumference of the circle. So there's my formula for surface area or area, and I'm going to substitute in what I know. So again, this pi r squared and this pi r squared are the same. So I'm going to put that in there using that whole value off my calculator like I'm supposed to. Plus 2 times pi times r, which is given to me to be 5, and then multiplying that by what I just found for the height to be 102, whatever. And again, I'm going to type all that in my calculator using those whole values, and I'm going to end up with an area of 3,280 once I round to 3 sig figs. That's an 8. And then area units are centimeters squared. So there's my answer to part 3. All right, and then part B, which you can barely see there, it's all hidden up in the other words. Part B says, state whether Nadia's design is practical. Okay, so think about this. The waste paper bin that she has created has a radius of 5 centimeters, which means it has a diameter across the whole top of the bin of 10 centimeters. Well, I know that there are 2.54 inches in a centimeter. We usually think better in inches than centimeters. So that means that the top of my waste paper basket is just under 4 inches, which is quite small. Probably not very practical. As you're shooting your paper in there, you're probably not going to make it. So I'm going to say no, it is not practical because it is too narrow. Okay, so if you need to pause the video so you can write some of that down, go ahead and do that. All right, I have the mark scheme here for us to look at so that you can follow what we've done and how you're going to get points. So question A is worth 2 points. You get 1 point for your method for substituting in, and then 1 point for the correct units. There does not seem to have been a unit penalty on this, but we have no way of knowing that ahead of time. Part 2, again, they're going to give you a method point for your correct substitution, and then your final answer point for that rounded correctly answer. All right, and you will get your follow through points there. So if you happen to get part A wrong, part 1 wrong, it'll follow through to part 2. Part 3, where they've substituted in, you're going to get a method point for this substitution, which we haven't already done. That's the curved surface area part. And then you're going to get the other method point for remembering to add those two things together. And then your final answer point here. And again, follow through points just like usual. And then notice that in order to get your answer point, you also have to get your reason point. You can never receive A0, R1. So depending on what you get there, you could say it's too tall because of the height, or you could end up saying that it is too narrow, which is kind of what we went with. Okay, let's move on. So the next part, write down an equation in H&R using the given volume of the bin. Okay, so those sections might be a little bit confusing, which is why I wanted to spend some time looking at an actual IB question. Write down an equation in H&R. Basically, that means write the formula for volume and use the variables H and R. Okay, so the formula for volume equals the area of the shape on the bottom times the height. So there is the answer to part C. I have written down the formula using that, and now it says use the given volume. So now instead of that V, I want to use the 8,000. All right, so the only thing I've substituted for here is the 8,000. We must at this point be moving into Marin's idea because we're no longer using the 5 for R. So we're done with Nadia's waste paper baskets and we're moving to Marin's at this time. Okay, so let's look at D. Show that the total external surface area of the bin is that. Okay, so external surface area, we already looked at this. And we know that that's going to be pi r squared plus 2 pi r h. Okay, so look at what they want us to show right here and look at what we know to be true from the formula. What I noticed to be different is that this second part, the curved surface area, has an h and this one doesn't. So when it asks me to show that, I must be doing a substitution here to get rid of that h. So in the directions, remember when I told you guys sometime you're going to need an extra formula so that you can optimize your variable? This is one of those situations. So my extra formula is this one. The thing that Marin wants to do, Marin wants to minimize the total surface area. So what Marin is focusing on is this. But see, we can't do this right now because we have both an R and an H, and you guys don't know how to take derivatives with two different variables in there. We can only have one variable like this. So IB is going to prompt you to change from this situation that you cannot work with to this situation which you can work with. Okay, so somehow I'm going to need to get rid of that H, which is the reason why they asked me to do this. If I can solve this for H and substitute in here, that will eliminate my problem. It'll help me make it look like this. So I'm going to go back right here and I'm going to divide by pi r squared on both sides. And this is what I'm going to substitute in place of h. Okay, so let's see. I've got pi r squared plus 2 pi r times what I have figured out to be equivalent to h, which is this. Okay, well, I still haven't shown this. This needs to simplify a little bit. So let's see what we can do here. I see that I have a pi that will cancel out. and I have one r here and I have r squared right here. So if I cancel out one of those r's, I'll just be left with r to the first. All right, so let's see what this does for us. Now I have pi r squared plus, all right, 2 times 8,000, that's 16,000. And in the denominator, I just have r. All right, well, that's what I wanted. So now I have the formula that I wanted. Remember, for a show that question, you have to end up with what they have right here. So let's see how we did on the mark scheme. All right, I'm going to get 1 point for this. It really wasn't very difficult to substitute 8,000 into the volume formula, so they're only going to give me 1 point. Then they're going to give me 1 point for correctly rearranging part C. This step right here is worth 1 point where I solved for H, and then a method point for substituting that in. So a method point for this part, and then I'm going to end up with the final thing that I have here. Okay, so that's where my points are going to come from. One thing that IB is very particular about, as we move forward to parts E and G, F and G, you must use, you must use this. So if you cannot get there, the reason why they gave you this in D is so that you have the correct formula to move forward with. If you struggle to get there, do not use your wrong formula. You will not get follow-through points for that. You must use the formula that they have given you in D because they're telling you this is the right formula, so use it as you move forward. Okay, now we're going to get to part E. Part E says find dAdr. Well, if you think about our original situation here with Marin, we're going to minimize the surface area. See the word minimize right there? I know I'm going to take derivative. And again, IB is going to kind of prompt you. Now you want to take that derivative. So if I use that formula that I just found, it would be easier if I moved that r up to the top. So I'm going to have pi r squared plus 16,000 r to the negative 1. Now I can take the derivative. So dAdr pi r squared. Now pi is not a variable. Pi is a constant. The only variable that I have here is r. So I'm going to move the 2 down in the front, 2 pi r. And then negative 16,000, I'm sorry, positive 16,000 times negative 1 is going to give me negative 16,000 r to the negative 2. All right, and then I'm going to go ahead and rearrange that so that I have 2 pi r minus 16,000 over r to the positive 2. I'm just going to move that back down to the end. The reason why I'm doing that is because I look ahead here in F and it says find the value of r that minimizes the total surface area. Well, I see that word minimize. That tells me I'm going to take the derivative and I'm going to set it equal to 0. And it's just a lot easier for me to work with if I don't have negative exponents. Okay, so I look at this, I have a fraction. Fractions automatically make me think perhaps proportions. So I'm going to add the 16,000 over r squared to the other side. And I'm going to make this 2 pi r over 1 so that now I have a proportion. I can cross multiply. 2 pi r to the third equals 16,000. I'm going to divide both sides by 2 pi. All right, and I did that already so that I would have it. And now I'm going to take the cube root of both sides, 13.7. All right, now, normally at this point, I would do a sign diagram, but I'm getting ready to run out of time, so I'm telling you the sign diagram is going to work, and the units there would be centimeters, but you do want to do a sign diagram to get your points. Find the value of h that corresponds to that. Well, I have to go back to the equation that I found in part D, and the equation was 8,000 over pi r squared equals h. And I'm going to substitute that in. And then h is going to be 13.655, rounds to 13.7. And yes, it is an improvement. Oh, and I need to have centimeters on there. Yes, it is an improvement because it's wider and more stable.